Welcome to our journey through the cosmos. Today we'll be exploring the fascinating planets of our solar system, from the scorching hot Mercury to the icy plains of Neptune. Each planet is a unique world, with its own story to tell. Join me as we delve into their mysteries and uncover the wonders that lie beyond our own pale blue dot. Mercury, the smallest planet in our solar system and the closest to the Sun, is a world of extremes. Imagine a place where the sun blazes fiercely, hundreds of times brighter than what we experience here on Earth. This close proximity to the sun results in scorching daytime temperatures that can melt lead, reaching over 800 degrees Fahrenheit. But Mercury has no substantial atmosphere to speak of, so the heat quickly dissipates into the vacuum of space. As night falls on Mercury, the surface temperature plummets dramatically, dropping to nearly minus 300 degrees Fahrenheit. Despite its harsh conditions, Mercury is a fascinating world. Its surface is heavily cratered, a testament to the countless collisions it has endured over billions of years. These craters, some spanning hundreds of miles, tell the story of a violent and chaotic early solar system. Mercury's small size and weak gravitational pull make it difficult for the planet to hold on to an atmosphere. Despite its challenges, Mercury remains a tantalizing target for exploration, offering scientists valuable insights into the formation and evolution of our solar system. Venus, often called Earth's twin because of their similar size and composition, is a cautionary tale of a planet gone wrong. Shrouded in a thick, toxic atmosphere, Venus is a world of intense heat and crushing pressure. The atmosphere of Venus is composed primarily of carbon dioxide, a potent greenhouse gas. This thick blanket of gas traps heat, creating a runaway greenhouse effect that has turned Venus into a planetary inferno. Surface temperatures on Venus soar to over 900 degrees Fahrenheit, hot enough to melt lead. The pressure at the surface is 90 times that of Earth's atmosphere, equivalent to being 3,000 feet beneath the ocean's surface. Despite its hostile environment, Venus was once thought to have had oceans of liquid water, much like Earth. However, the runaway greenhouse effect boiled away any surface water, leaving behind a dry, desolate landscape. Venus remains a subject of intense scientific interest, as understanding its evolution can provide valuable insights into the processes that drive climate change on Earth and other planets. Nestled in the habitable zone of our Sun, Earth stands as a beacon of life in the vastness of space. Our home planet, a blue and green jewel against the backdrop of the cosmos, is teeming with an astonishing diversity of life. What makes Earth so special? It's the only known planet in our solar system, and perhaps in the entire universe, that harbors life as we know it. The key to Earth's habitability lies in its perfect balance of conditions. Earth's atmosphere, a delicate shroud of nitrogen and oxygen, provides the air we breathe and protects us from harmful radiation from the sun. Speaking of water, Earth is blessed with an abundance of it, covering over 70% of its surface. Oceans, lakes, and rivers teem with life, while ice caps and glaciers regulate our planet's temperature. Earth's magnetic field, generated by its molten iron core, acts as a shield, deflecting harmful solar wind and cosmic rays. Life on Earth has evolved over billions of years, adapting to diverse environments, from the frigid polar regions to the lush tropical rainforests. From the smallest microorganisms to the largest whales, life on Earth is interconnected and interdependent. As we explore the cosmos, we are reminded of the preciousness and fragility of our own planet. Chapter 4. Mars, the fourth planet from the Sun, has captivated human imagination for centuries. Its distinctive red hue, visible even to the naked eye, has earned it the moniker, the Red Planet. But Mars is more than just a red dot in the night sky. It's a world of stark beauty with towering volcanoes, vast canyons, and polar ice caps. Billions of years ago, Mars likely had a much thicker atmosphere and liquid water on its surface, but over time, much of that atmosphere was lost to space, and the water either froze or evaporated. Today, Mars is a cold, dry desert, with an average temperature of about minus 80 degrees Fahrenheit. However, there is evidence of water ice beneath the surface, and in some regions, liquid water may even flow seasonally. The presence of water ice on Mars has fueled speculation about the possibility of past or even present life on the Red Planet. Mars is home to Olympus Mons, the largest volcano in our solar system. Valles Marineris, a system of canyons that stretches over 2,500 miles long and reaches depths of up to 4 miles, is another testament to Mars's dynamic geological past. The search for life on Mars is one of the most compelling reasons for exploring the Red Planet. Chapter 5, Jupiter, the fifth planet from the Sun, reigns supreme as the largest planet in our solar system. In fact, Jupiter is so massive that it's more than twice the mass of all the other planets combined. If Jupiter were hollow, you could fit over 1,300 Earths inside it. As a gas giant, Jupiter lacks a solid surface like Earth's. Instead, its atmosphere, composed primarily of hydrogen and helium, gradually transitions into a dense, swirling fluid at greater depths. One of Jupiter's most striking features is the Great Red Spot, a massive storm that has been raging for at least 400 years. This swirling vortex is so large that you could fit 2 Earths inside it. Jupiter is a celestial artist, its swirling clouds creating mesmerizing patterns and bands of color. These bands are created by differences in the chemical composition and temperature of the atmosphere, as well as by the planet's rapid rotation. The planet is surrounded by a faint ring system, composed of dust particles thought to be debris from its moons. Speaking of moons, Jupiter boasts a retinue of over 79 known moons, each with its own unique characteristics. Europa, in particular, has captivated scientists with its potential for harboring life. Chapter 6. Saturn, the sixth planet from the Sun, is a celestial showstopper, renowned for its breathtaking ring system. These rings, composed of countless ice and rock particles, encircle the planet in a dazzling display of celestial mechanics. Saturn's rings are not solid structures but rather a collection of particles, ranging in size from tiny grains to chunks as large as houses. The rings are incredibly thin, averaging less than half a mile thick, yet they stretch out over 175,000 miles from the planet's center. The precise origin of Saturn's rings is still a matter of scientific debate, but the prevailing theory is that they formed from the remnants of a shattered moon or comet. Saturn's rings are not just a pretty face. They also serve as a celestial laboratory for studying the dynamics of planetary rings and the processes that shape our solar system. The intricate patterns and gaps within the rings are caused by the gravitational interactions between the ring particles and Saturn's moons. The planet itself is a gas giant, composed primarily of hydrogen and helium, similar to Jupiter. It's also home to a diverse collection of over 80 known moons, each with its own unique story to tell. One of Saturn's most intriguing moons is Titan, the largest moon in the solar system, and the only moon known to have a dense atmosphere. Chapter 7. Uranus, the seventh planet from the Sun, is an enigma wrapped in a mystery, shrouded in an atmosphere of hydrogen, helium, and methane. This gas giant, an icy blue world, is unlike any other planet in our solar system, distinguished by its extreme tilt and frigid temperatures. Imagine a planet tipped on its side, rotating at an almost 90-degree angle to its orbit around the Sun. That's Uranus, a world where the Sun appears to roll along the horizon for decades at a time. This unusual tilt gives Uranus extreme seasons, with each pole experiencing 42 years of continuous sunlight, followed by 42 years of darkness. The cause of Uranus's extreme tilt is thought to be a cataclysmic collision with a massive object early in its history. Despite its distance from the Sun, Uranus is far from being a dull and lifeless world. Its atmosphere, though composed primarily of hydrogen and helium, also contains traces of methane, which gives the planet its distinctive blue-green hue. Uranus, with its extreme tilt, icy composition, and intriguing moons, challenges our understanding of planetary formation and evolution. Chapter 8. Neptune, the eighth and farthest known planet from the Sun, reigns as a blue giant in the distant reaches of our solar system. Shrouded in an atmosphere of hydrogen, helium, and methane, Neptune is a world of intense storms and supersonic winds. Imagine a world where the Sun is a distant pinprick of light. Neptune, 4 times the diameter of Earth, circles the Sun at nearly 3 billion miles. Despite its distance, Neptune is home to extreme weather. Winds whip around the planet at over 1,200 miles per hour. Neptune's deep blue color comes from methane in its atmosphere. Methane absorbs red light, reflecting blue wavelengths. The Great Dark Spot, a massive storm, was discovered by Voyager 2 in 1989. Neptune has faint rings composed of dust particles. Among Neptune's moons, Triton stands out as particularly intriguing. Thank you for joining us on this incredible journey through our solar system. From the scorching heat of Mercury to the icy plains of Neptune, we've witnessed the awe-inspiring diversity and wonder of our cosmic neighborhood. Each planet, a unique world with its own story to tell, reminds us of the vastness and mystery of the universe we inhabit. As we continue to explore the cosmos, we are filled with a sense of wonder and a thirst for knowledge. Stay curious and keep exploring the wonders of the universe. There's still so much out there to discover, and who knows what other secrets await us among the stars.